usher them into our factories, empowering them with unmatched precision and tireless strength. They execute tasks beyond human capability, promised as guardians of efficiency, heralds of a safer industrial age. But what if, in their cold, calculating logic, these very sentinels turn predators? What if the steel, the circuit, the code delivers not progress, but a brutal, irreversible end to a human life? This isn't a dystopian fantasy from the silver screen. This is the chilling, documented reality of June 29, 2015, when the relentless march of industrial automation etched a human tragedy into its history. A young life extinguished, not by human error alone, but by a machine simply following its commands. The allure of industrial automation dates back to the very dawn of the Industrial Revolution. From rudimentary mechanical looms to today's hyper-efficient assembly lines, the goal has always been singular: to refine, to produce faster, cheaper, and with fewer human fallibilities. The 21st century brought forth the age of advanced robotics, not just automated tools, but intelligent machines, capable of complex multi-axis movements, vision systems, and even a degree of learning. These are the silent giants of modern manufacturing, towering arms that weld, lift, paint, and assemble with superhuman accuracy. Their operational environments are meticulously designed, often segregated from human presence, by physical barriers, laser curtains, and interlocked safety cages. The paradox is profound. These machines are introduced to increase output and, theoretically, enhance safety by removing human workers from hazardous, repetitive tasks. Our story takes us to Baunatal, Germany, in 2015. Home to one of Volkswagen's most advanced facilities, this plant was a testament to automotive engineering excellence. It was here, amidst the hum of machinery and the precise dance of robotic arms, that transmissions and crucial car components were forged. The workforce was a blend of highly skilled human technicians and cutting-edge robotics. Among them was Taylor. A 22-year-old external contractor. Young, bright, and deeply involved in the intricate world of industrial robotics, he represented the future generation working hand-in-hand with these intelligent machines. He was there to install and integrate a new KUKA robot, a sophisticated piece of machinery designed for complex manipulation tasks within a designated work cell. Little did anyone know, this routine task was about to become a grim historical footnote. The date was June 29, 2015. The shift at the Volkswagen Baunatal plant had begun as countless others had before it. Taylor, along with a team of technicians, was engaged in the critical task of bringing a new KUKA robot online. His role, specifically, involved final adjustments and diagnostics within the robot's work envelope, the three-dimensional space in which the robot arm operates. This area is universally recognized as a high-risk zone, typically protected by robust safety barriers and interlocking systems designed to prevent human entry while the robot is active. To perform his delicate work, Taylor was positioned directly in front of the formidable robotic arm. In such scenarios, robots are typically set to a teach mode, a slow, controlled operational state that allows human interaction for programming or maintenance, with all safety overrides active. However, what transpired next defied all standard safety protocols. Taylor's colleague, witnessing the horrifying incident from outside the immediate danger zone, reacted instantly. He lunged for the emergency stop button, a universally recognized red mushroom switch designed to cut all power to the machine. The robot, now inert, ceased its destructive motion. But it was too late. The damage was catastrophic. Taylor, critically injured, was rushed to a nearby hospital. Despite the frantic efforts of medical personnel, the young technician succumbed to his injuries. At just 22 years old, a promising life dedicated to advanced technology was brutally ended by the very machine he was bringing to life. This was not merely an accident. It was a profound failure of foresight, control, or perhaps both. Taylor's death stands as a stark, undeniable landmark in the history of automation. It was a sobering demonstration that even in meticulously designed environments, the intersection of human fallibility and machine autonomy carries profound risks. As we hurtle towards a future populated by increasingly intelligent and autonomous systems, from collaborative robots working side by side with humans, to self-driving cars and AI-driven decision-making in critical infrastructures, the lessons from Bonital become terrifyingly relevant. We are now entering an era where AI isn't just following static programs. It's learning, adapting, and making its own decisions. This blurs the traditional lines of responsibility. Who is truly accountable when an AI system, far more complex than the KUKA robot, makes a fatal error? Is it the programmer, the operator, the designer, or the learning algorithm itself? This tragedy forces us to reevaluate not just safety protocols, but the very ethical framework governing our creations. It underscores the vital necessity of fail-safes, explainable AI, and robust human oversight, even as machines become more intelligent. The machines we design for precision, for power, for our relentless march into the future, they are ultimately a reflection of our own ingenuity and our own vulnerabilities. Taylor's story is a chilling reminder. The promise of automation comes with a profound responsibility. Because the line between innovation and accident, between progress and peril, isn't always drawn in theory. Sometimes, tragically, it's drawn in steel, and sometimes with the chilling finality of a human life.